Yeah, awesome. We got the recording, and we get 20 people, so that's perfect. Yeah. So again, thank you so much for being here, Andrew. Really appreciate it. Because yeah, thank you so much. Because it's very special for us. It's the first time we actually have someone from Aragon at these AMAs. It took us a while to finally get someone, and of course, Aragon is a very interesting project. A lot of innovation coming from you guys. So I'm sure the fellows are curious to learn more about it. But before we get into the Aragon and all the core development, I would like to get to know you a bit more, Andrew. Like just to just to learn about your background. Like, can you maybe tell us a bit more about how did you start working on Ethereum? What did you do before? How did you get into the core development in the first place? Yeah, it's your
Uh,
story.
right. Yeah. So joined the blockchain community about 5 years ago. Well, more than 5 years ago, in the beginning of 2019. And it was my friend and colleague Alexei Akunov, the original founder of Aragon, who actually invited me into this space. And before that, I actually, well, of course, I had heard of blockchain, but I hadn't worked on it. I've been a software engineer throughout my career, but before that, I worked in banking. And around 2017, 2018, I tried to work on my own startup, which involved augmented reality. And I wasn't able to secure funding, so I had to shut it down. But Alexei suggested this opportunity to me to work on what was called TurboGeth back then. So yeah, I decided to jump in. And to be fair, to be honest, it took me quite a while to get up to speed, and it was difficult for me to switch from working in the office to working remotely. And also to blockchain has a steep learning curve. But like after this initial period, I'm very happy that I'm in blockchain and working on Ethereum, because I think for talented software programmers, it's a great place to be. A lot of there are many rabbit holes that you can go down, and yeah, and you can go really deep if you want to.
Yeah, awesome. Thank you so much, Andrew. Yeah, that's interesting. So you knew Alexei before, because yeah, that's interesting. It's awesome. So yeah, Alexei is the creator of TurboGet, which forked Get, then turned into Aragon under its own branding. And I still remember Alexei being in EF in like 2020, first time I talked to him, and then like it evolved. So and now it's actually quite big. Like there is so many efforts. So my next question is more like, what is actually Aragon right now? Like, it's not just a single client. I mean, there is you already mentioned Aragon 3, 4 before. There is Silkworm. There used to be Aquila. So maybe can you give us a bit of an overview of what is happening now, like what the Aragon team does?
Uh, right. Yeah. I think we've had quite a few projects, maybe too many for our own good. But yeah, I can give an overview. So historically, we had projects in three different languages. In Go, which is Aragon, the original TurboGeth, and then I think it was 2020 when I was actually so I was a little bit pissed off by what I perceived as over-engineered code in Aragon. So some of it was inherited from Geth, some of it was because of our own kind of over engineering or hacky code. And I wanted to write some clean implementation, and I knew C++ at the time, and I liked C++, and I still like C++. So, and Alice, the original C++ client, was kind of dying around at the time, and there was another project called EVM1, and it's still going strong. It's one, I believe it started as a hobby project, but by one of the Ethereum Foundation developers, Pavel Belitsa. So it's a very fast EVM implementation in C++. So Silkworm started kind of as a wrapper over EVM1, and the scope of that project has been morphing throughout the years, and now we want to use it as a library for in Aragon, our Golang client, for computationally heavy bits. And also we want to switch our EVM execution to EVM1 plus Silkworm completely, because EVM is one of the few bits still relatively unchanged compared to Geth. So switching to EVM1 plus Silkworm will increase client diversity, and it will re-architecture and redesign one of the last remnants of Geth in Aragon's code base. And also, maybe it was 2021, I'm not too sure, but we had a developer who liked our designs, like our data models, and who is very passionate about Rust. So he started this project Akula in Rust, but then at some point when Rust began, and they started in earnest, and they also were on the path of open sourcing it. He got discouraged because he didn't want to compete with them, basically. Thus we closed the Akula project. But I think like trying to develop 3 clients is a bit too much. So maybe 2 or 1.5 is already a good target. In terms of our other projects and strength, I think like historically, the strength of Aragon was as an archive node. When we started using Geth and as an archive node was painful, and I'm sure that they've improved since then, but it was taking forever to sync Geth, and the disk footprint was very high. So like I guess the original core innovation of Aragon was to optimize that scenario, the archive node, and we are still not done with this task. One of the projects that we are delivering right now, well, we still haven't delivered it yet, but we have released an alpha version, is Aragon 3, and it introduces the transaction level granularity of state history, which means that you can do historical tracing of a transaction much faster, because like if your state history granularity is on the block level, then in order to trace a transaction, you first have to have a view of the historical state of the beginning of the block, and then re-execute all the transactions from the beginning of the block to the transaction in question, which can take a while with the transaction level granularity of state history can jump directly to the necessary required state. So that's one improvement of Aragon 3. And another improvement is that we are actually putting a lot of data in what we call snapshot files, which are immutable or virtually immutable, and because of that, you can download them over BitTorrent. And now, in order to sync Aragon 3, you can download state plus state history pretty much over BitTorrent. And with our current production version, which is Aragon 2, you download state. You have to re-execute all the blocks from Genesis in order to arrive to the current state, which you can imagine is quite slow. Yeah, what else? What other projects do we have? We maybe a year ago or so, we started a project codenamed Captain to implement the consensus layer. What we call it internally the real merge. So it's like merging two pieces of Ethereum into a single piece of software. And we are also a multi-blockchain client. We support, besides Ethereum, we support Gnosis chain and Polygon. I think those are our major projects.
Yeah, thank you so much. Yeah, it's quite a lot. I mean, the Erigons and Silkworm and also Kaplan integrated. It's very useful to be able to just run the client like we used to, just a single binary. So yeah, yeah, thank you so much, Drew. And we already are getting some questions in the comments. Before we get there, I wanted to have one more question, just specifically more about your focus. What do you focus on? What are your tasks? What kind of work are you dealing with these days?
So yeah, I have primarily two roles. I work on the Ethereum EL side of Aragon. So I participate in the EL OCO dev calls and keep a track of the progress of Ethereum's roadmap. And I with my colleagues implement some of that. And to some extent, I'm also the CTO of Aragon, so I have to do some kind of managerial or admin tasks.
Awesome. So you have also the organizational role. I didn't realize that. That's interesting. Thank you so much, Andrew. Yeah, awesome. Yeah. So, folks, if you have any questions, always feel free to raise your hand. We got some in the comments, so I'm gonna start with that. The one that I find interesting is whether you guys are thinking about getting history data from Portal Network, or whether you are thinking about integrating with Portal because you already work with the torrent. So I think that like it's could be another module there. Yeah.
Yeah, we thought about it, and I think for us it makes sense to be a provider of data for Portal Network, because probably like Portal Network is essentially a distributed hash table, and it might be not optimized for our use case, which is to sync like a lot of data, so terabytes of data, of if you want a full if you want an archive node. So I don't think I haven't run any tests, or I'm not aware of any tests, but I imagine that it would be quite slow with the Portal Network because it's just simply it's not the use case it's been optimized for. But because we actually have all the data, we can be the provider.
Yeah, I'm looking forward. I mean, I'm actually asking because I'm kind of looking forward to seed the portal with my Aragon node. So I'd love to contribute this way. We have a question from Katya.
Yeah, Chirag was first. Is he? Okay.
Yeah, his head is down. So yeah, go ahead.
Hi, Andrei. I have two questions. Thank you for coming. I have some confusions about interaction of execution layer and consensus layer, and this is my chance to make it crystal clear. So could you quickly make an overview of a transaction flow, how it switches between execution and consensus layer, and what's the time window of execution layer in the slot when a transaction is executed? Because later it goes to for attestation, and this period in the slot, I wonder.
Right. Yeah. To be honest, I know little about the consensus layer, and I don't remember the exact timings. But overall, like how the flow works is that now blocks we have beacon chain blocks that are superset of execution layer blocks. So like the execution layer blocks inside the beacon chain blocks are called execution layer payloads. So those blocks are propagated over the beacon chain network or the consensus layer network. And when a validator receives a new block, it asks its peer execution layer to validate the block, because the EL client, it has all the state, like the kind of the EL state, the main state of Ethereum, and CL clients, they have some state, but it's a much smaller state in terms of so they have things like validator sets, things like that. But the bulk of Ethereum state is on the EL side, and in order to execute an EL block, you need to access to the state, at least until Verkle comes along. So yeah, so it has to, CL has to ask and does ask the EL to execute that execution payload, and specifically, among other things, verify that after executing all the transactions inside the EL block, the resulting state root matches what's there in the header, in the block header. It's kind of because the state root is a commitment scheme, which guarantees you that you are committing to that specific state. That's the most time-consuming verification bit. Yeah, and then that can be a reason for missed attestations if the EL is quite slow in terms of block execution. Then the CL will be slow to actually to find out that the EL block is valid. And the Aragon probably right now is not very good at it, because it's so it kind of works, but we still haven't optimized this performance on the tip of the chain fully, and that I believe we have potential in that area. Yeah, so does it answer your question?
Yeah, so at the beginning, when the validator even has not yet propagated the block, the transactions go to the mempool, right? It's on the execution client. Yeah.
Okay. So there are kind of two. Okay, there are two scenarios. So when there are beacon, if a validator is like each slot, a validator is chosen randomly or pseudo randomly to produce a block, and that's one scenario. So for block production, it has some time to produce a block, and it asks the EL to do so, and what EL does is it looks at the transaction pool, which essentially, or the mempool, which has pending transactions, and starts adding new transactions to a block. And then at some point, the CL might tell the EL, okay, time is up. Like, stop now, wrap things up, because like you need also to finalize a block. Like you need to calculate the state root and do some other small things at the end of a block, and then the EL just returns that execution, that EL block, i.e. the execution payload, and the CL wraps it inside a beacon chain block, and propagates it over the network. So that's one scenario when it actually is building a new block. And what I talked about previously is the attestation scenario when someone else produces a block, and all network participants have to attest to the validity of that block. But both cases, like there might be in terms of like slowness and timing, there might be different bottlenecks. So the network speed can clearly be a bottleneck. The sheer like speed and latency of your network, because you have to propagate potentially large blocks. That can be a bottleneck, but also EL performance on the tip of the chain. So how fast you can either verify or existing block, or build a new block by adding transactions. Like you add transactions until you are told to stop.
Thank you. That's the topic I would like to add to EPF Wiki, because we have the general scheme how layers interact, but there would be nice to add a flow. Yeah, like Mario, where it starts and how it goes between the clients. Thank you.
Yeah, like the closest to this is the Daniel's documentation from it was Daniel from the previous cohort on the engine API, guys. Somebody knows what I'm talking about if you have it. It's the secondly doc. I can share it here later, but definitely this could be improved. Yeah, yeah, and thank you so much for the answer, Andrew. Folks, yeah, if you have any questions, yeah.
I'd like to note on that theme. It's a related discussion that we had internally in the team. Is that like before the merge? Block in the proof of work world. Like EL nodes were self-sufficient, and they relied on the EL peer-to-peer to propagate new blocks, to gossip new blocks, and so on. But effectively, after the merge, the only use case and some of it is still there after the merge. But by and large, if you consider EL peer-to-peer, we can perhaps bypass it. It's only really strictly speaking, it's only necessary for transaction propagation for the mempool, but for block propagation, we can rely on the beacon chain on the beacon chain on the CL peer-to-peer. And we thought about actually switching off EL peer-to-peer and using it or like keeping it only for the mempool. But I think there are kind of maybe CL clients are not fast enough in terms of retrieval of historical blocks. But conceptually, now blocks live on the CL side, and EL, like EL peer-to-peer doesn't have to propagate them. It still does, but conceptually that's redundant. Anyway, sorry, it was a side note.
Now, thank you so much for adding that. We have a question on the design from JS Visa. I'm not sure if you want to read it. JS Visa, feel free to open your mic. Otherwise, I will read it. The Ergo E3 will store the state as transactions instead of blocks, so it will really increase the performance of transaction-related APIs. But as a disadvantage, will the storage and times bigger in blocks? Will the, I guess, whether disadvantage is the storage size? Yeah.
Right. So if it depends on the state history, on how the state changes and how you store it. Because if on like you can imagine two extreme scenarios. One scenario is that inside a block, all transactions touch the same data, the same, say, the same account and the same storage. Then if you compare the two granularities, that clearly like switching to the transaction level granularity will make your state history or n times bigger, right? Because there will be a lot of changes to the same state, and on the block level you can collapse it into a single change. But most transactions are not like that. They actually touch different pieces of the state, and if you imagine the opposite extreme case where each transaction touches different accounts, then there is no change in the footprint, right? Because you can, if you are clever about storing the state changes, you only store what's necessary. Then you can switch to this transaction level granularity without any increase in the footprint. And of course, the real situation is somewhere in between. But what we did in Aragon 3, we also used better compactification algorithms, and especially what we did with the state history, that we have a system of overlays such that you kind of your and also that's true not only for state history but for the state itself, kind of split your state into state that was touched recently and state that was touched a long time ago. And if that partition is stable in time, i.e. you have that system of overlays, but maybe you do say like your time partition is say every every 1 million blocks or so on, and that partition stable in time implies that your old files, they never change. And if you have some immutable set of data, some immutable map, some immutable hash table, you can use you can do some pre-processing to compress it even further to compare to the case of a hash table that you can change dynamically. So you can use techniques like the perfect hash table for better compactification of the data. So that's what we do in Aragon 3. And the end result is that it depends on the blockchain, but I think for all blockchains, so for both Ethereum and Polygon and also for Gnosis chain, actually the disk footprint is reduced in Aragon 3 despite the switch to the transaction level granularity.
Awesome. That's very interesting optimization. Thank you so much, Andrew. Yeah, awesome. Churek, do you have a question?
Yes, I do have a question. Sorry, yeah, I've been having troubles with my mic. But in like when you were introducing your background, you mentioned that you had to fix a lot of over-engineered code, and I think Ethereum in general right now is plagued with over-engineered code. in many places, in most clients. Do you like, first question is, what would you attribute this to? And would you necessarily like attribute this to like a scarcity of product managers in the Ethereum core development itself? I'm not sure of that. Yeah.
Right. Okay, that's a good question. What's yeah? Why do we have over-engineered code? I think one reason is some of the complexity is intrinsic or is due to the protocol, and kind of if you consider the Ethereum protocol itself, then some of its complexity is historical and some of it is justified, and kind of I am a big fan of making things simpler, but it's not easy. Like making things simple is very, very hard. But yeah, so some of the complexity of the code base is due to the fact that the protocol itself is complex, but some of the complexity is probably due to of Aragon's code base is due to two reasons. First, we inherited we started as a fork of Geth, and you know that reading others people code is hard. So sometimes if you're not part of the original team, you don't have the full context, and you try to work with the existing code base, but because of your lack of understanding or context, you make it even messier than it used to be. That's one reason, and another reason that I think sometimes we were in a hurry to prove something, like to prove that our ideas about the state representation and the data models, they actually work. And I think we've proven that, but because of that, because of the time pressure, we had some technical debt. Also, I think maybe in the past we were a little bit too ambitious, and I'm not sure. It's a good thing, but when you try to when we had what we called internally our trilemma. So we have to pursue pretty much three goals. We have to keep up with Ethereum's roadmap, and Ethereum, it hasn't ossified yet. It has I think quite significant innovations and changes. So we have to implement those and participate in the discussions. We also have our own technological roadmap, which I think is quite ambitious. We have to do that. And then we have the product quality and the users and the user experience and so on and support. So which is also takes a lot of effort. And yeah, I think maybe we were not good at achieving all of our goals because there were too many of them. But how can we solve those issues, or how can we improve? I think delivering Aragon 3, which is well, maybe not around the corner, but I think it will happen in a few months' time. Maybe it will give us some breathing space in terms of our technological foundations. So we don't need, we will not have to reinvent the foundations again and again, because it's quite costly to change the foundation of your house. And also, I think we will continue on enhancing our test suite. So all kinds of automated tests. So unit tests, integration tests, and end-to-end tests. Because I think if you have a complicated code base and you want to evolve it, then the only way you can clean up technical data and do refactorings is to have a really good, decent test suite. Because otherwise you make a change and you don't know whether you break things horribly or not. Right? Yeah. Yeah.
Yeah, feel free to follow up. Yeah.
Yeah, it's not. Yeah, sorry. It's not more of a follow up per se, but I think I've just mostly heard team managers say that there are a lot of short-term contributors more than long-term contributors in the open source community, and that causes like a code to be not maintained for long term by one person, and then like just multiple authors coming in. But anyways, I had another question regarding EIP44s for a client like Aragon, which is focused on archive nodes, and there being a 1 out of n trust model for EIP4, like after 4 4s, that is.
Sorry, I missed the second part. Like the first part was Aragon is focused on the archive node, and what was the second part?
Yeah, with 4 4s, like EIP44s, it pretty much like there's only going to be 1 year of history maintained, I assume. And like, how will Aragon fit into like a post 4 4s world? That is
right. Yeah. Okay. Yeah, that's a good question. So yeah, I think like historically, the strengths of Aragon has been as an archive node, but we believe that with Aragon 3 that we have the technological foundation to actually improve our performance as a full node, or even like, I don't know, maybe is some kind of lighter node, but yeah, that's mostly about the future. How about 4 4s? So like the way it was in Aragon 1, it was problematic because Aragon 1 had to re-execute all the blocks from Genesis to get up to the current state, but those blocks had to be obtained from somewhere and from the EL peer-to-peer network. Thus, it wouldn't be possible in the 4 4s world. But with in Aragon 2, what we did snapshots not of the state but of the historical blocks and put them on BitTorrent, and we did them. The partitioning of the historical blocks is stable in time, meaning that files containing all the blocks that they never change or change very rarely, which actually means that even Aragon 2 is compatible with the 4 world. Like it's kind of it can live fine in that world because it has its own mechanism of distributing historical blocks. And Aragon and Aragon 3 can actually sync the state itself, so it doesn't have to re-execute all the historical blocks, which means that it can actually benefit from the 4-force world because it can also emit some older blocks, and we already have kind of three pruning modes in Aragon 3. So the no prune mode is for the archive node, where you don't prune anything. Then I think the prune mode for, maybe it's called the full mode. I'm not too sure, but it basically corresponds to the full node and without 4-force. And we also have this mode which we call minimal, but it's essentially 4-force, where we prune historical blocks because those are not needed for, say, for the validator. And I think we also, in terms of all nodes living in the 4-4 worlds, I think that's a bit inaccurate, because you still want some archive nodes, or you want some entities to store historical blocks of Ethereum for research purposes, or for like if someone is super paranoid and wants to re-execute all the historical, like do the Genesis sync, then there should be a way to do that. So I think we are offering our own proprietary, like at the moment it's proprietary in the sense that it's not well documented solution in terms of our snapshots, and we want to document it and make it well specified so that others can join. But what I'm trying to say is that there is actually value in having things like Aragon archive nodes, or Reth archive nodes, or the Portal network that provide some means of retrieval historical blocks. But most of Ethereum in the 4-4 world, most validators and most Ethereum nodes will not have old blocks. Yeah.
Yeah. Thanks for the answer.
Thank you so much. Thank you so much, also JS Visa, for quickly sharing the documentation. Yeah, folks, any questions? Feel free to raise your hands, and we have Katya again. Yeah, go ahead.
Yeah, so Aragon has embedded consensus layer. Yeah, could you tell more?
Yes, so that's the project Kaplan in Aragon 2. It's off by default, and in Aragon 3, but it's still possible to switch it on in Aragon 2, and in Aragon 3 we want to make it the default. It's and currently we are working on implementing Spectra changes there.
Do you have the plan to make like a full validator embedded into the Aragon?
I think we maybe at the moment we don't have plans to implement their kind of that relatively small process that actually holds the validator keys. I'm not sure the official name for it, but that's official term, but I would call it the keeper, right? But that's a very lightweight process that actually, and when, like, for the moment we are happy to use Lighthouse or another CL implementation but for that small bit. But for the bulk of the CL logic, so for the beacon chain node, we are working on its full implementation as Project Kaplan inside Aragon's code base. And yeah, we want to. It's kind of not super polished yet, but we will keep working on it and keep improving its performance.
I guess not only keys, but 32 ETH also.
Right. So, okay.
Yeah, got it. Thank you.
32 is yeah, but I mean, probably access to that bit is controlled by the keys, right?
Yeah, and of course, like you can run the client with some pool, which lets you do much less than that. So, yeah. Thank you so much, guys. Boma has a question.
Okay, good afternoon. I don't know if this is out of proportion, but I have a question in regards to trying to um do something related to minimum validator participation in Ethereum Beacon chain. Like, do you have like pointers on how to go about this?
Sorry, could you repeat it? I didn't quite get it.
Okay, I said I don't know if this is the right question for you, but I feel like you might have an answer or something. Um, do you have any pointers on how to check on minimum validator participation on Ethereum Beacon chain?
But what do you mean by the minimal validator participation? Like sorry, is it related to client diversity, or yeah, again, I'm not very knowledgeable about CL, so maybe I'm just misunderstanding something.
Care to elaborate, Boma? I also
Or do you mean the 32 ETH requirement to like the
I think maybe we lost. Yeah, we lost her. It was a connection problem. I'm sorry about that. But we still have enough time. She will be back, hopefully. Do you have any other questions meanwhile? Um, yeah. Um, yeah. Chirac?
Actually, yeah. So it's also following up on EIP44's. Like I really just want that EIP in Ethereum so that I can rent out better VPSs for lower cost. But anyways, so since Aragon has already worked with BitTorrent and also tested the reliability of BitTorrent for storing history blocks and snapshots, there is this ongoing debate of whether they should take in Portal Network or if they should take BitTorrent in for storing the history. Generally, it does not really matter, but like which step would Aragon take, and like has Aragon already formalized any analysis in this respect? BitTorrent versus Portal client in general, yeah.
Right. So I haven't been involved. I haven't looked into the Portal network in depth myself. I know that some of my colleagues looked into it, and there is some interesting cryptography in the Portal network, or that might be beneficial. It's kind of what. With currently with our current model in Aragon, we rely on social trust a little bit. We produce we run a set of Aragon nodes to produce what we call the snapshots. So like files containing state history, and historical blocks, and we publish hashes of those files or on a GitHub repository, and so we have some kind of mechanisms and tools to check that the produced snapshots are all right, but it's not very decentralized. So like ideally, we would like to use the blockchain itself as a means to to publish to commit to those hashes. And I know very little, but maybe that's something that the Portal network has done, or at least looked into it. I'm sure that something similar is. I kind of heard that something similar is done in terms of big beacon. On the CL side, you have some cryptography, some aggregators where you can commit to a range of, you can verify maybe a range of blocks, but I'm out of my depth here. But basically, what would be interesting is to via a smart contract or some other means to actually to publish commitments to blockchain history on the blockchain itself in a secure manner. That would be cool. But I don't have concrete ideas for that yet. So, but I think ideas from the Portal network might be helpful in terms of practical implementation. As I mentioned in the beginning, we can probably provide data for the Portal network. I just have suspicion that it's not optimal for us to sync from it. To just be too slow.
Yeah, like we had Colby from Portal actually at this AMA like a few weeks ago, and he was very bullish on Portal, of course. But honestly, like I feel that Aragon got us even closer to the 4.4. Like so, the requirement for the 4.4s is to have some reliable alternative to peer-to-peer network to serve the data, and Aragon, which is integrated, I think, with the torrent, works really well. Like that's the torrent is like we have the Portal network is like torrent with extra steps, right? We already have the torrenting solutions for a couple of years, and now like I think the one big problem is compatibility or standardization here, because for example get has the ERA files. I'm not sure if you've seen that. So there is a torrent for like all the pre-merge history ERA files, and you can easily verify them and import them to Get. But it would be nice to have this sort of torrent for the, which can work easily with all the clients. And then also like Portal, I really like have multiple solutions. But I think that like Aragon really did a great job on this. Torrenting it without those extra steps. Yeah. Anyway, we have Boma back. Maybe do you want to repeat your question because we lost you? Otherwise, we still have a few minutes for another question. Yeah. Okay, Katya, go for it. You're leading
just if
today.
anyone doesn't have any questions. Yeah, I have some confusing parts in the work of execution layer. So another question is about storage, because I know storage from the smart contract developer perspective, but from the peer-to-peer network, is it just like database and it is on the consensus layer?
So, well, no, storage is actually part of the kind of what I consider the main state of Ethereum, and it's on the EL side. So it comprises like accounts plus storage. They comprise the bulk of the state of Ethereum. So there is some state on the CL side related to say validator set and so on, and also blobs, which are ephemeral but still like you're supposed to store them for a while. Yeah, but that's smaller. That's smaller than the EL side. So you can think of it as a key value database, essentially. Yes. the key is, and you can have like different key schemes and an interesting, like if you are into the key schemes and you want to go we want some advanced stuff, then you can look at Verkle and how the key scheme is done there. But like for currently, like for like one simple way is like the key is the account address and the storage slot address. You just combine the two parts into this composite key, and the value is the value, which is a 32-byte number, and you can encode it compactly so that like initial zeros like are left out in the RLP encoding. But essentially, it's a key value database. And you commit to that state currently via the Merkle-Patricia tree, but going forward with Verkle. And from our perspective, from Aragon's perspective, what's interesting is that the keys, like when you consider the EVM itself, the EVM execution, it operates on the plain keys. But when you calculate the commitment, the Merkle-Patricia root, it actually hashes the keys, and it introduces some kind of inefficiencies in terms of data access, which we're trying to mitigate in Aragon 3. But that's, I guess, that's a different discussion.
Yeah, my main question was about the database stored in execution layer. Yeah, thank you. And the blobs, they store the data from L2s, right?
Yeah.
Thank you.
Thank you so much for the answer. And that was the last question because we are at a full hour. We gotta wrap it up here. But yeah, thank you so much again, Andrew, for being here. It's been a great hour, great AMA, and thank you everyone who asked the question. Thank you so much for the great session. Yeah, I think we learned a lot. We get inspired. Really appreciate it, man.
Thank you for hearing me, and thank you for the great questions.
Yeah, of course. Yeah, really appreciate it. And yeah,